How's grade 12? So today we're going on to rate of change. So these first couple of examples I'm just going to shoot through because they're relatively easy. So you can follow in the PowerPoint, I'll post them up. So the first example is saying, express the following problems symbolically. So question A, they're asking for to write this symbolically, the rate of change of x with respect to p. So it's the rate of change of x, the change of x with respect to p equals 5. The rate of change of x with respect to p is 5. Okay, question B. They're asking the rate of decrease of volume meters cubed with respect to time s is 4. So you've got the rate of decrease of volume. So it's the changing volume with respect to the changing time is 4. But now they've told us that it's a decrease. So a decrease needs to be a negative, and they've given us units here. So it is meters cubed per second. Okay. Then question C. Still the same thing, express the following problem symbolically. So it says here the rate of decrease of y with respect to x is proportional to x. Now before I get on to this, I just want to show you what a direct proportion looks like. So y directly proportional to x. Okay. Now to get rid of this proportionality sign, what we do is we introduce a constant of proportionality. So y is equal to kx. As soon as I bring in this constant of proportionality, this proportion sign will change to an equals. And that's what we're going to do here. So it's the rate of decrease of y. So it's the changing y with respect to the changing x is equal to x. But because it's a direct proportion, I must put my constant of proportion there, and it is a decrease. Okay. Now, what I need to do is I just need to put a restriction on our k here, and I must just say that k is greater than 0. Because if k was negative, then this would become a positive, then it would be an increasing rate. And that's not what we want. We want a decreasing rate. All right. Question D, the rate of change of L with respect to V. So the rate of change of L with respect to V is inversely proportional. So I'm going to do this again over here. So we've got y is inversely proportional to x. Now to get this to an equation, we say y, bring in your constant of proportion, and as soon as I do that, it becomes an equals. Okay, so that's what we're going to have here. It is inversely proportional to v squared. Inversely proportional to v squared. Okay. Example 2. Okay, example 2 is saying a large tank is being filled with water. The volume of the water is given by V of t is equal to 5 plus 10t minus t squared, where the volume is in meters cubed and time is in hours. So I just want to make a note here. Volume is in meters cubed and the time is in hours. Okay. Question A. Find the rate at which the volume is increasing when t is equal to 1. Now, what they've given us here is a function of the volume at any time point. Now, if you want to find the rate of change of the volume, what you would do is you would find v dashed of t. That is the rate of change of this. So if we differentiate this, we get 10 minus 2t. But they're interested in a particular time when t is equal to 1. So I'm going to find v dashed of 1, and we get 10 minus 2 times 1, and that gives us 8. Now, what we have to do is we just have to bring in our units here. Now, you remember, V dash T is exactly the same as saying dV dt. Okay, so what we got here is the units for volume is meters cubed over, and then the units for time is hours. So this would be meters cubed per hour. All right. Question B. After how long does the tank start overflowing? All right. So if you think about this, if you've got a tank, all right, and the water level is at some height, and you're filling this up with a hose, and the water's coming in there at some rate. Now, as soon as this starts overflowing, your water level is going to be up at the top here, okay? And automatically what you're going to do once it gets to that point is you're going to turn off the hose pipe. So you're going to stop putting water in. So as soon as you turn the tap off, the rate of change of the water coming out the hose pipe is 0. There is no water coming out. So that is what I'm going to do here. I'm going to find V dashed of T, and I'm going to set it equal to 0. In other words, I'm taking the rate, setting it equal to 0. So we've already got V dash T, so that's 10 minus 2T equals 0. If you solve for this, you'll get T is equal to 5. Okay. Therefore, it overflows after 5 hours. All right. Example 3. Okay, example 3 is saying the predicted circulation of the local newspaper in T years is given by this function. C of T equals 50 T cubed minus 200T plus 3000. Okay. Question A, so this is the number of newspapers circulated at some time. All right. Question A, what was the circulation at the time of first publication? So at first publication, no time has elapsed yet. So your time would be 0. So what we're going to do is we're going to find C of 0. And we get 50 0 cubed minus 200, 0 plus 3000. And that gives you 3000. Therefore, 3000 papers were initially circulated. Okay. Question B. What is the minimum circulation to the nearest number of newspapers? Now, to find a minimum or a maximum in calculus, you need to take the derivative and set it equal to 0. All right, and why we do that is because we're finding the turning points. And the gradient at your turning points is 0. So because this is a cubic, and I'm not going to draw it exactly how it is, but a cubic would look something like this. Okay, so you can see you have a maximum here and a minimum there. And that is what we're going to find. So I'm going to find C dashed of T and set that equal to 0. So C dashed of T, that's going to give us 150T squared minus 200 equals to 0. And if I solve for T here, I'm going to get T is equal to 1,1547, and it goes on. And what they want to know is the minimum circulation. So what I've found is the T value that would correspond to a minimum. I'm going to take this, put it back into the original, and I'm going to find that circulation. So C of 1,1547, and that gives us a value, if you put it in your calculator, of 2,846,03. But what they want is to the nearest newspaper. So I'm just going to round this down. So this is approximately equal to 2,846 newspapers is the minimum circulation amount. All right, so grade 12, so what I'm going to go on to now is average speed. Okay, now just remember when we started calculus, you had two types of gradient. You had your average gradient and your instantaneous gradient. Now, when we spoke about the average gradient was between 2 points. Your instantaneous gradient was a gradient at a point. So your average speed is going to be between two speeds, okay? And it is basically just like your gradient formula, okay? Changing y over the changing x. So average speed will be equal to the changing s over the changing t. Okay, the changing your displacement over the changing time. All right, so example 1. Example 1 is saying the distance s in meters traveled by a particle in time t in seconds is given by s of t equals 4t squared plus 1. It goes on to say, determine the average speed during the third second. Now, this is where you guys get a little bit confused. Because the third, or during the third second, is going to be between the second and the third second. Okay, so if I had to draw this up, we have 0 seconds, 1 second, 2 seconds, 3 seconds. Okay, and let me just draw one more, 4 seconds. So if we have a look here, we're looking during the third second. So this between here and here is during the third second. We can't take it more than the 3 here, because then that would be more than 3 seconds, okay? For example, like 3.1, 3.2, 3.3. That is more than 3 seconds. It is not during the third second. We are looking for over here, okay? For example, over here, this would be between during the first second, between the second, between the third second, between the fourth second, and so on. Okay, so what I need to do is, for this, the average speed is going to be equal to the changing s over the changing time. So our changing s is going to be our displacement, or our distance at the third second, so s of 3 minus the displacement at our second, all over. Now our time here is 3 minus our time here is 2. And if we put 3 into here, we're going to get 9, 36, 37. Minus, if we put 2 in here, that's 4, 16, 17. All over 3 minus 2 is 1. So we get here 37 minus 17 is 20 meters per second. So that is our average speed during the third second. If we look at example 2, example 2 is saying the distance s in meters traveled by a particle in a time t in seconds is given by s of t is equal to t squared minus 6t. Determine the average speed between t is equal to 2 and t is equal to 2 plus h, and explain what happens as h tends to 0. All right, so we know that the average speed is going to be equal to the changing your displacement over the changing time. So it's going to be s of 2 plus h minus s of t, all over. Now our time for this one here, sorry, this is going to be 2 So it's between 2 and 2 plus h. Now, our time for this one here is 2 plus h, minus our time for this one is 2. Sorry guys, it's the kitten jumping around doing crazy stuff. Okay, so what I'm going to do is plug that into there, and we get 2 plus h squared minus 6 2 plus h minus 2 squared minus 6 times 2 all over. The bottom here, I can sort this out. 2 minus 2 cancels, and we just left over h. Okay, so if I FOIL this very quickly, we're going to get 4 plus 4h plus h squared minus 12 minus 6h. That's going to give us 4. 4 minus 12. 4 minus 12 is going to give us minus 8. But it'll become a plus 8. Okay. All over h. Let's get like terms together here. So we get h squared minus 2h. And then we've got that, and that'll give us 12, so that cancels all over h. I can take out a common h. H is cancelled, and we're left with h minus 2. Okay, so that's our average speed. Now, it goes on to say that what happens as h tends to 0? Well, as h tends to 0, then we're just left with minus 2. Okay, now that is possible because, just for those of you that do physics, just remember it's a vector. So it just means you're going in the opposite direction. So it would be minus 2 meters in the opposite direction if h tend to 0 for this. Okay, right. Let's have a look at speed at an instant. So you remember what I said? You had instantaneous gradient and average gradient. Right, so what I want you guys to do with this one is I want you to remember this. S is for your displacement or your distance, V is velocity or speed, and A is acceleration. Now, if you're going in this direction, you're going to differentiate. Okay, if you're going in this direction, you're going to find the area under the curve. Or integration, okay, which I'm not going to talk about. So, if you are given a displacement or a distance function and you want to find the velocity, you would differentiate it because you're going in this direction. Let's say that you're given a distance or a displacement function and you want to find the acceleration. You would have to differentiate it twice. Okay. Don't worry about going in this direction. That's a whole nother topic. All right. So if we look at example 1, it's saying to us here that a projectile travels according to the equation of motion S of t is equal to minus 2t squared plus 8t, where S is in meters and t is in seconds. All right. So what we've got here, because S is in meters, this is a displacement or a distance function, this one over here. Then question A. The distance traveled after 3 seconds. Well, we have the function for distance, so I'm just going to plug in 3 for our time. And we get minus 2, 3 squared plus 8 times 3. And if you work that out, we get 6 meters. So it traveled 6 meters in 3 seconds. Question B, the speed at t is equal to 3. Now, what we want to work out is speed. So there is our speed, velocity. So we are given this function over here, displacement, okay? We need to go in that direction, so we need to differentiate. So I have to find s dashed of t. And if we differentiate this, we're going to get minus 4t plus 8. So now I have the velocity function, okay? And they're interested in when it is 3 seconds. So s dashed of 3 equals minus 4 times 3 plus 8. And if you work that out, we get minus 4. And we just have to put the units in. It's meters per second. Again, grade 12s, don't worry about the negative. It's because it's a vector, it has direction. All it means it's in the opposite direction that it was going. Okay. Then, having a look at question C, the speed at which it leaves the ground. Okay. So we're going to use this function over here because s dashed is your velocity. Now, when it leaves the ground, your initial time there is 0. It hasn't moved anything just yet. It's just as it leaves the ground. So s dashed of 0 gives us minus 4 times 0 plus 8. I'm just getting it from this function over here. And we get 8 meters per second. All right. Question D. The time it takes to reach the highest point. Now think about something here, guys. If you throw a stone up, so initially there it is, and you throw it up, what's going to happen? Eventually it's going to stop at its apex there, and then now it's going to start coming back to the ground, and then it hits the ground over here. Okay. So at its peak, they want to know the time it takes to reach its highest point, which is this point over here. So as it goes up here, it starts slowing down, slowing down, slowing down, slowing down. And then what happens over here? Its speed is 0. Then it starts coming back to the earth, and then it starts picking up speed. So I know that our velocity would be 0. So s dashed of t will be 0. Okay. So we've got minus 4t plus 8 equals 0. And if you solve for that, you get t is equal to 2, and it's seconds. So it takes 2 seconds to reach its highest point. Okay. Example 2. Right, example 2 is saying the motion of a particle is defined by s of t is equal to 9 minus 6t plus t squared, where s is meters and time is in minutes. Okay, question A. Calculate V3 and explain what this value means. Now what we've got is we've got S. Now in order to find V, we've got S. In order to find V, we have to differentiate. Okay. So I know that V of T will be equal to S dashed of T. So let's find S dashed. So we get minus 6 plus 2t. And that's our V of t. And what they want is they want V of 3. So V of 3 equals minus 6 plus 2 times 3. And we get 0. Now they're asking us, what does this mean? Well, if our velocity is 0, that means, therefore, the particle is stationary. Because its speed is 0, it's not moving, so it is stationary. Question B, determine expression for A of t and explain. Now, if we go back to this, we worked out from our S, we worked out our V. Now, in order to get to A, I have to differentiate V to get to A, okay? So we know that A of t will be equal to V dashed of t, okay? So if I differentiate my V over here, what are we going to get? We're going to get 2. Now, that is a constant, okay? So what that means to us is that we've got here meters per second squared. That means that, therefore, the acceleration is constant. And what it's saying for every second, your velocity is increasing by 2 meters per second, okay? Because it's the rate of change of your velocity. All right, so grade 12s, that is it for your handout 4. Thank you very much.